Hi, I am Teacher Daisy. Now, let's learn Form 4 Mathematics Chapter 3 Logical Reasoning. In this chapter, you will learn 3.1 Statements, 3.2 Arguments. 3.1 Statements. A statement is a sentence, of which the truth value can be determined, that is either true or false, but not both. For instance, 4 plus 4 equals 8 is a true statement, 4 plus 7 equals 8 is a false statement. Question, exclamation, and command sentences are not statements, because the truth values of these sentences cannot be determined. For instance, how do you come to school? Please send the workbook. Watch out for the car. X plus 3 equals 5 are not statement, because the truth value cannot be determined. Example: determine whether the following statements are true or false. If it is false, prove it. Solution: A. X plus y squared equals x squared plus 2xy minus y squared, where x does not equal 0, y does not equal 0. False. Let x equals 2 and y equals 3. X plus y squared equals 2 plus 3 squared equals 25. X squared plus 2xy minus y squared equals 2 squared plus 2 times 3 minus 3 squared equals 7. Hence, x plus y squared does not equal x squared plus 2xy minus y squared. B. X plus 5 squared less than 0, x is the element of real numbers. False. 2 plus 5 squared equals 49, greater than 0. C. 2 plus 6 times 4, greater than 4 plus 6 times 2. True. Example: determine whether the following mathematics statements are true or false. A. All polygons have diagonals. False. Triangles do not have diagonals. B. Some perfect squares are whole numbers. False. All perfect squares are whole numbers. C. All even numbers have prime factors. True. Negate a statement. We use the word no or not to negate a statement. The negation of statement P is written as -P. The truth values change from true to false, or vice versa through the process of negation. Example: form a negation for each of the following statements, P, using the word no or not. A. 12 is a multiple of 5. 12 is not a multiple of 5. B. 41 is a prime number. 41 is not a prime number. C. All multiples of 5 are multiples of 10. Not all multiples of 5 are multiples of 10. D. 0.4 meters is equal to 400 millimeters. 0.4 meters is not equal to 400 millimeters. Determine the truth value of a compound statement. A compound statement is a combination of two or more statements by using the word and or. The word and in a mathematical statement means both, while the word or means one of them or both. Example: combine the following statements, P and Q, by using the words 1 and 2 or. A. P. A pentagon has 2 diagonals. Q. A heptagon has 4 diagonals. Solution: 1. A pentagon has 2 diagonals, and a heptagon has 4 diagonals. 2. A pentagon has 2 diagonals, or a heptagon has 4 diagonals. B. P. A pyramid has 5 planes. Q. A pyramid has 5 vertices. Solution: 1. A pyramid has 5 planes and 5 vertices. 2. A pyramid has 5 planes or 5 vertices. Example: determine the two statements, P and Q, in the following compound statements: A. 5 plus 3 greater than 5, and 5 minus 3 less than 5. B. 9 and 91 are prime numbers. Solution: A. P. 5 plus 3 greater than 5. Q. 5 minus 3 less than 5. B. P. 9 is a prime number. Q. 91 is a prime number. Example: determine the truth values of the following compound statements. A. 2 and negative 5 are greater than 4. B. X plus 3 less than X minus 5 and 99 is an odd number. Solution: A. 2 is greater than 4. False. Negative 5 is greater than 4. False. False and false is false. B. X plus 3 less than X minus 5. False. 99 is an odd number. True. False and true is false. Construct a statement in the form of an implication. Implication: if P, then Q. A statement: if P, then Q is known as an implication where P is denoted as the antecedent. Q is denoted as the consequent. Example: form an implication if P, then Q, with a given antecedent and consequent. A. Antecedent: K is divisible by 5. Consequent: K is a multiple of 5. If K is divisible by 5, then K is a multiple of 5. B. Antecedent: set K is a subset of set L. Consequent: NK less than or equal to NL. If set K is a subset of set L, then NK less than or equal to NL. Implication: P if and only if Q. An implication P if and only if Q consists of the following two implications: if P, then Q; if Q, then P. Example: form an implication P if and only if Q, with the following implications. If K is a prime number, then K has only two factors. If K has only two factors, then K is a prime number. K is a prime number if and only if K has only two factors. Construct and compare the truth value of converse, inverse, and contrapositive of an implication statement. If Ali is a prefect, then Ali is a disciplined person. Statement: if P, then Q. Converse: if Ali is a disciplined person, then Ali is a prefect. Converse: if Q, then P. Inverse: if Ali is not a prefect, then Ali is not a disciplined person. Inverse: if negate P, then negate Q. Contrapositive: if Ali is not a disciplined person, then Ali is not a prefect. Contrapositive: if negate Q, then negate P. Example: write the converse, inverse, and contrapositive of the following implication. If X is a positive number, then X is greater than 0. Statement: if X is a positive number, then X is greater than 0. Converse: if X is greater than 0, then X is a positive number. Inverse: if X is not a positive number, then X is not greater than 0. Contrapositive: if X is not greater than 0, then X is not a positive number. 1. The truth value of contrapositive is the same as the truth value of an implication if P, then Q. 2. The converse and inverse are contrapositive to each other. 3. The converse and inverse also have the same truth value. The truth value of an implication if P, then Q is always true, except when P is true and Q is false, happen at the same time. If an antecedent is false, then the implication if P, then Q is always true, without depending on the truth value of the consequent. Example: determine the truth values of statement, Converse, inverse, and contrapositive of the implication: if 2 times 3 equals 6, then 8 minus 2 times 3 equals 18. Statement: if 2 times 3 equals 6, then 8 minus 2 times 3 equals 18. Antecedent: true. Consequent: false. Truth value is false. Converse: if 8 minus 2 times 3 equals 18, then 2 times 3 equals 6. Antecedent: false. Consequent: true. Truth value is true. Inverse: if 2 times 3 does not equal 6, then 8 minus 2 times 3 does not equal 18. Antecedent: false. Consequent: true. Truth value is true. Contrapositive: if 8 minus 2 times 3 does not equal 18, then 2 times 3 does not equal 6. Antecedent: true. Consequent: false. Truth value is false. Determine a counterexample to negate the truth of a particular statement. For a false statement, at least one counterexample can be given to negate the truth of that statement. For example, the statement "all polygons have 2 or more diagonals" is false, as a triangle does not have a diagonal. The triangle is a counterexample to support the false value. Example: determine the truth value of the following mathematical statements. If it is false, give one counterexample to support your answer. A. The sum of interior angles of all polygons is 180 degrees. False, because the sum of interior angles of a pentagon is 540 degrees. B. Some prime numbers are even numbers. True. Example: write the mathematical statement requested in the brackets for each of the following. Then, determine the truth value of each statement written. If it is false, give one counterexample to support your answer. A. All multiples of 10 are multiples of 2. Negation: B. If x greater than 5, then x greater than 3. Converse: C. If x is a root of x cubed minus 1 equals 0, then x equals 1. Inverse: D. If k squared greater than 0, then k greater than 0. Contrapositive. Solution: A. Negation: not all multiples of 10 are multiples of 2. False, because all the multiples of 10 are divisible by 2. B. Converse: if x greater than 3, then x greater than 5. False, because 4 greater than 3, but 4 less than 5. C. Inverse: if x is not a root of x cubed minus 1 equals 0, then x does not equal 1. True. D. Contrapositive: if k less than or equal to 0, then k squared less than or equal to 0. False, because -2 less than 0, but -2 squared equals 4 greater than 0. 3.2 Arguments. Meaning of an argument, difference between deductive and inductive arguments. The process of making a conclusion, based on statements, is known as argumentation. An argument can consist of several premises and one conclusion. A premise is a statement that gives information before making a conclusion, and a conclusion is an outcome or a decision. The specific statements are statements that refer to a particular case, while the general statements are statements that describe a concept. Deductive argument is a process of making a specific conclusion based on general premises. Inductive argument is a process of making a general conclusion based on specific premises. Example: determine whether each argument below is a deductive argument or an inductive argument. A. All acute angles are less than 90 degrees. Angle PQR is an acute angle. Thus, angle PQR is less than 90 degrees. Premise 1. All acute angles are less than 90 degrees. General. Conclusion. Then, angle PQR is less than 90 degrees. Specific. B. The sum of exterior angles of a triangle is 360 degrees. The sum of exterior angles of a quadrilateral is 360 degrees. The sum of exterior angles of a pentagon is 360 degrees. Thus, the sum of exterior angles of each polygon is 360 degrees. Premise 1. The sum of exterior angles of a triangle is 360 degrees. Specific. Conclusion. Then, the sum of exterior angles of each polygon is 360 degrees. General. Determine and justify the validity of a deductive argument, and determine whether the valid argument is sound. A deductive argument is said to be valid if all the premises and the conclusion are true. Premise 1. All actresses are good at dancing. Premise 2. Jasmine is an actress. Conclusion. Jasmine is good at dancing. The above argument is a valid argument. Although we know that premise 1 is false, not all actresses are good at dancing. But this argument is still valid, because the argument fulfills form 1. But the argument above is unsound because premise 1 is false. Example. Are the following arguments valid and sound? If it is not, justify your answer. A. Premise 1. All multiples of 16 are even numbers. Premise 2. 64 is a multiple of 16. Conclusion. 64 is an even number. Valid and sound. B. Premise 1. All basketballs are in spherical shape. Premise 2. The Earth is in spherical shape. Conclusion. The Earth is a basketball. Not valid, because it does not comply with a valid form of deductive argument. Not sound, because the conclusion is false. Form a valid deductive argument for a situation. Example. Form a valid deductive argument for each of the following situations. A. All mammals are warm-blooded. Cats are mammals. Cats are warm-blooded. Premise 1. All mammals are warm-blooded. Premise 2. Cats are mammals. Conclusion. Cats are warm-blooded. B. If x is greater than 0, then x has a positive value. 6 is greater than 0. 6 has a positive value. Premise 1. If x is greater than 0, then x has a positive value. Premise 2. 6 is greater than 0. Conclusion. 6 has a positive value. Example. Write a conclusion for the following deductive arguments to form a valid and sound deductive argument. Premise 1. All whole numbers are real numbers. Premise 2. 38 is a whole number. Conclusion. 38 is a real number. Example. Write the premise for each of the following deductive arguments to form a valid and sound deductive argument. A. Premise 2. 37 is a prime number. Conclusion. 37 has only 2 factors. Solution. Premise 1. All prime numbers have only 2 factors. B. Premise 1. If the annual sales of ANC company exceeds 3 million, then the employees get a bonus of 3 months' salary. Conclusion. The annual sales of ANC company do not exceed 3 million. Solution. Premise 2. The employees of ANC company do not get a bonus of 3 months' salary. Determine and justify the strength of inductive argument, and determine whether the strong argument is cogent. A deductive argument emphasizes the validity of the argument, while an inductive argument emphasizes the strength of the argument. The strength of an inductive argument is determined based on the probability that the conclusion is true, assuming that all premises are true. To determine an argument that is cogent, or not cogent, it needs to be discussed based on the truth of the premises and its conclusion. The number of premises does not guarantee a strong argument. Because the strength of an argument depends on the truth value of the conclusion. A weak argument is not cogent, while a strong argument will only be cogent if all its premises are true. Example: determine whether the given arguments are strong or weak. Hence, determine whether the strong argument is cogent or not cogent, and justify your answer. A. Premise 1. The chairs in the living room are red. Premise 2. The chairs in the dining room are red. Premise 3. The chairs in the study room are red. Premise 4. The chairs in the bedroom are red. Conclusion: all chairs in the house are red. This argument is weak and not cogent because although the premises are true, the conclusion is probably false. B. Premise 1. 27 is a multiple of 3. Premise 2. 81 is a multiple of 3. Conclusion: all multiples of 9 are multiples of 3. This argument is strong and cogent because all the premises and conclusion are true. Form a strong inductive argument of a certain situation. A strong and cogent inductive argument depends on the true premises and conclusion. The given premises are the evidence or support to the conclusion made. Inductive reasoning can be carried out in the following steps. Observe some examples or specific situations. Observe the common features. Make a general conclusion. Example: form a strong inductive conclusion for each of the following number sequences. Solution: a. n to the power of -1, where n equals 1, 2, 3, 4, and so on. B. 0.5 to the power of n, where n equals 1, 2, 3, 4, and so on. C. 2n plus 1, where n equals 0, 1, 2, 3, and so on. D. 3n to the power of 2 minus 3, where n equals 1, 2, 3, 4, and so on. The concept map for Form 4 Chapter 3 is as below. If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.